boom, 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 boom. And in 3, 2, 1, we're live. All right, welcome everybody. Today we're going to be doing a review of the August 2023 conference called Neuroscience Needs a Revolution, hosted by Dr. Stuart Hammeroff, and I was a speaker at that event. So we'll be doing a review of that, and also, just kind of talking about what I learned and what I figured out from that event. It was very cool. I hope you guys were able to, some of you were able to at least watch the live stream. Should you want the replay, I will be posting that on September 1st when it becomes available. So you'll be able to see my full presentation there. But before we do that, let's just do a quick simultaneous squeeze. So let me just put this here in the chat, simultaneous squeeze. Okay, so first we're going to take a deep breath in, take another sip of air at the top. Then we're going to hold that in for 5 seconds, really squeeze it in. And then you're going to take an exhale like that for like 5 seconds. Okay, so ready? In 3, 2, 1, breathe in. Take a sip, hold and squeeze. And exhale. Just like that. Very nice. And I kind of feel like almost like I want to wobble a little bit. And that's totally natural. Feel a bit of a heating in my body. Definitely feel different when I do that. So cool. Awesome. TK, good to see you here. So I did this event this weekend. I was in Encinitas, California, August 20th to the August 19th to the 20th is when I was there. I gave a talk, but I also got to listen and watch other people talk. Some of the people that I watched, basically a majority of the people speaking there were neuroscientists, doctors, physicists, nanomaterial specialists. And the main goal of this event was to popularize some of these deeper concepts within neuroscience that haven't yet risen to the surface. In the neuroscience field, they almost used technology that was like invented in like 1875. Yeah, right, Joanne? In your hood, sorry we couldn't get you some more sunshine. It's okay. When I got back to Seattle, we have tons of sun up here. So I got all the sun I need. Very strange scenario where Seattle would be more sunny than San Diego, but that's just how things worked out with Hurricane Hillary. So no worries. I had a great time either way. So great people, great friends. It was like literally the best vacation, best birthday present I've ever had, to be able to go down there for August. So in attendance were a ton of incredible speakers, incredible minds, people who really just like at a fundamental level really like get and understand that in neuroscience, so neuroscience is kind of broken as far as I could tell. So we have, there's let's say that there's 3 main divisions where neuroscience works. First is the first highest, well, maybe the bottom floor level of neuroscience is theoretical neuroscience that happens in academic circles. So in universities and colleges and research institutions, that is where neuroscience is explored and discovered and practiced. Once they develop a practice from neuroscience, like maybe it's a brain stimulation or EEG or psychotherapy, even something like that, all developed in academia, translates into like hospital-based, from doctor to patient or from therapist to patient. That's where it's practiced. So there's the theoretical level of neuroscience, there's the in-practice version of neuroscience, and then there's the consumer grade like neuroscience. This is like what you and I tend to know about what neuroscience is. Practically speaking, let me ask if you guys wouldn't mind. If I were to say neuroscience to you, what does neuroscience mean to you? I'm just curious, what does that mean to you? In the traditional framing, where you kind of, so you know the term like the trickle down theory or the drip down theory, they use it like economics, like, well, if all the billionaires make a bunch of money, then they'll have to spend money and their wealth will trickle down to the small people, right? So it's similar in this bubbling up effect from academia to doctors to consumers of neuroscience benefits. So some of the benefits that we have today from neuroscience at the very bottom are things like psychotherapy, modern medicine like drugs like SSRIs, because an SSRI pill is supposed to work in your brain, and it's a neuroscience application of what they developed in academia. You typically see a huge lag time, unfortunately, between what is fundamentally or theoretically discovered to where it's practiced to then when the consumer receives it. So today, some of the things that you guys might be wearing, like some of these watches that track your sleep, some of the watches that track your heart rate variability, some of the drugs that you take today for mental health, some of the knowledge that you have about how the brain works. Like, well, we have a reptilian brain and we have a limbic brain. We have a prefrontal cortex and executive center. We have different parts of our brain that control different parts of our body. That's all more common knowledge today because of the theoretical neuroscience that's happened over the last 100 years. So, of course, think about it like this. If I were to just wake up one morning and think, wow, I can see things in my room and I'm hungry, that's not a very advanced way of looking at your neurology, your neuroscience, basically. It took academics to like crack open the brain and go, ooh, if we put a needle here, that makes your left arm go like that. So they could start mapping out how the brain works and kind of create like a functional map. Once that started to happen, then they could develop theories on, well, when someone is in a car accident and they have a brain lesion, we now know that it's not because the person's not acting out because of demon possession. It's more because they have like a tumor growing in their brain and it's compressing against part of their brain and they're acting out in the way that's aligned with that damage to the brain. That is a result of neuroscience. But in places like brain scanning, fMRI machines, treatments, they are probably 30 to 50 years behind some of these even newer theories on consciousness and the mind. So think of it like this. The whole conference was called Neuroscience Needs a Revolution to Understand Consciousness. So consciousness, let me just timestamp this as because this is important. Okay, so yeah, Joanne, brain development. Yeah, so that's an incredible insight that we do have because of neuroscience. Without neuroscientific understanding of the brain, we wouldn't exactly understand how you go from like a baby through development, through adolescence, through teenage years, to adulthood. We wouldn't understand the connection between the brain. Part of that insight is how we discovered that, a 12-year-old shouldn't be smoking marijuana probably because it probably stunts brain development. Like that is an insight of neuroscience, which I think we should be grateful for. But in terms of consciousness, what is consciousness? That's a really key question. Consciousness is a hard to define term, but generally speaking, consciousness, as far as an academic understanding of it, as far as I know, is the understanding of how does our experience of the world give rise to something that we call consciousness. Like there's a fundamental question. I think it was a neuroscientist who asked, what would it be like to be a bat? So what would it be like to be in the mind of a bat? Would you experience things in the same way? Would your experience of reality be different? Is the consciousness in a brain of a bat, is that different than the brain of a human? Invariably, the answer would be that there are definitely differences. But then you look further down and you say, what's it like to be in the mind of an ant with a very much smaller brain? Does an ant experience reality in the same way that a human does? Like, does an ant have this beautiful individualistic experience of reality? Does it have a mind of its own? Or is an ant more like an automaton machine in a system? it would almost seem like, due to the mass intelligence of millions of ants creating a colony, is that ants individually don't seem to have the kind of consciousness that humans have. So there's a level of conscious experience that arises from the larger the brain becomes. And that gives us maybe a more rich experience of reality, right? So like you don't see, chimpanzees are rather intelligent, obviously, but they're not painting, they're not writing books, they're not, there's some activities that humans do that seem to transcend base levels of consciousness. So the question is, what makes a brain get to a certain size and then start producing Mozart and music and operas and television and technology? Like something, the genetic differences between a human brain and a chimpanzee brain are rather small and are separated by a few million years of development. But there's something that's key in that could explain why humans seem to have hit a explosion of intelligence. And we wonder, is that consciousness itself to some degree? Does consciousness give us this intuitive insight into reality in a way that other mammals lack? That is the fundamental question of consciousness research. Another way to look at it is, if you consider all human stories tend to have some almost spark of magic to them. In my life, I know that there have been pretty incredible, almost magical experiences where it might have seemed like all was lost in my path, but then suddenly something shifted, or I had this insight radically that changed the nature of my life entirely. So for instance, like using vagus nerve stimulation for the very first time back in 2017 was a fundamental shift in my own relationship to my own consciousness. I had that experience where I did ultrasound on my vagus nerve while doing Wim Hof breathing, and I had pretty much like almost a psychedelic experience, like a very powerful experience. And this whole Facebook group that we're in today, that I run, is the manifestation of one moment of expanded consciousness from using ultrasound. Now, the problem with neuroscience today is that it can't really explain how consciousness is developing. Consciousness, according to a neuroscientist in most hospitals or academia centers today, thinks of the brain as like a computer where there's like a neuron that's either active or inactive. And that if you have enough neurons going on and off, like ones and zeros in a computer, that you have the emergence of consciousness. But we know that if you measure an individual neuron and it's either on or off, that there's still consciousness in that neuron. So neurons are not just individual units of information, that even further into a neuron, at things called microtubules, that there are vast processing capabilities that are able to process information on a quantum level. So part of this Neuroscience Needs a Revolution to Understand Consciousness event invited a lot of quantum researchers. Quantum is no longer the domain. It's no longer cool to make fun of people who say that there's quantum stuff happening in our world. It used to be 12 years ago, 15, 20 years ago, like a big, whatever, scratch your nose kind of thing to anybody in academia who even thought or expressed outwardly the question, could there be quantum effects happening in the human brain? And they would say, no, that's not possible. Quantum effects in the human brain, there's no such thing. There's no possible way that could be happening. But now we have much more advanced quantum machines that can do things that we couldn't do before. And we're finding that quantum mechanics can explain more things about the human brain than we ever thought possible. Things like the observer effect, which is really wild. So there's a type of thing called the double slit experiment. Let me just put this here in the, 1 second. I just want to timestamp this. Double slit experiment. So there's something called the double slit experiment, which is where you take one, a light emitting source from a single photon, and you shoot that light through two slits. There's a double slit in a piece of paper here. And on the other side is a sensor that can determine if that photon either went like a bullet through the left slit or the right slit. But if you put this experiment in a dark box and you have nobody observing it, what you end up with on the other side is a wave that shows that there's an interference pattern between the two slits of light, which is a crazy thing, which means that light, when not observed by a conscious entity, it collapses, and a light photon is either going through the left side or the right side. But if you aren't looking at the photon goes through both slits at the same time, and then probabilistically ends up on the other end of the wall according to the probability of where it could be, like an interference pattern. So that's why in physics and chemistry, when you were a kid in high school, a particle is both a photon and a wave, meaning a wave is like a probability of where that photon is, but the moment you observe it, the waveform collapses to just one position in the spectrum of possibility, which is a crazy implication. It turns out, and yeah, Joanne, you're absolutely right. When we're talking about artificial intelligence, when people say that artificial intelligence will be intelligent like a human in no time, it's just around the corner. But AI is built on simple ones and zeros. So if we understand the brain to be a computer, like a 1 and a 0, then it would make sense that inevitably, if we just have a big enough computer that's just processing raw data, that eventually a computer will be as smart as a human being, and then eventually will be smarter than a human being. But once we start to identify that the brain itself can process quantum information, like what would be a good example? Let's say that you're trying to think of driving on a road trip. Let's say you're in San Francisco and you want to drive down to Los Angeles. There's generally two roads that you can take to drive to Los Angeles. One is through Highway 1, and then the other one is Highway 5, Interstate 5. So there's one on the highway on the coastline, and then there's Interstate 5, which is in the center of California. When your brain thinks of what options it takes, when you see yourself in California, your brain creates two separate possibilities at one time, and you're able to evaluate two options at the same time. So that's called a superposition of one or the other option. But as soon as you get in your car and you turn off and you turn to the left, now you're going to I-5, and then when you turn to the right, you're going to Highway 1. And at the moment that you make that decision, that observational decision, I'm going to go there, all possibilities to go in the other way are collapsed, meaning your future is determined by going down Highway 1. So that's kind of you could look at it as a classical problem. Oh, you're just processing information in a 1 and a 0 way. But quantum mechanics would say that when you think about a possibility, your brain is expanding into this waveform of statistical probability, and that you're actually evaluating like a quantum waveform in your mind. And then the moment that you make a decision, you collapse the waveform to one thing or the other, which is why some research has shown. So here's some evidence that we have for this. The brain, when you hear my voice, when these words go into your brain and through your ears, it technically takes your brain about 17 milliseconds to process what the word was that I just said. So there's a delay between when the words exit my mouth, go into your ears, and then are processed by your brain to create meaning. And then let's say we were having a conversation back and forth, and I said something, and then you said something back to me. According to the delay in processing time between how long it takes your brain to not only hear and digest what I said is 17 milliseconds, it takes another 50 milliseconds for you to draft a response to what I just said. And then that has to get sent through neurons, which takes another 70 seconds for you to speak it. So all in total, you're looking at like about over 120 milliseconds of time between the words vibrating off of my mouth, going into your brain, you thinking about it, processing it, formulating a response, and saying something back. But people typically are able to respond within about 80 milliseconds, which means that you've formulated an answer to the question far quicker than your brain has even been able to think of the response. And that's actually true. So think of the implications of that. That technically could indicate that your brain knows the end of my question before I've even said it, and you've already formulated an answer within the first few milliseconds of hearing what I asked. And the only way that that's possible is because in the quantum world, information can also move forwards in time and backwards in time. So that means that your brain creates a quantum space, like a spreadsheet of information over time. And because your brain knows that more words are coming, information from the future collapses, sends information back in time to you thinking about the question, and then you're actually able to formulate a response and then answer. And this is real shit. Like, this is actually observed. Neuroscience, as it's typically understood today, based on the delay time of speaking to each other, cannot take into account all the specific delay times in communication. So the only way that that's really possible is if we're either answering questions without really listening, and I know some people do that, but in real answers and questions, like I've asked you, did you see the color green or red more often today? You would be able to answer that quicker than you can even process the question. What was the food you ate for breakfast? It was toast. I had toast for breakfast, and I had coffee. So that casts huge levels of doubt in the model of neuroscience that the brain is some 0 and 1 processing computer, because all the times don't make sense. And so the only thing that really could make sense would be quantum information processing in the brain. There's lots of other studies that show this to be the case too. There's lots of other evidence that shows that there have to be quantum effects happening in the brain for brains to work. But neuroscience has not updated their model yet to make sense of this. And the reason why is because they're so reticent, they're so resistant to admitting that there are quantum effects happening in the human brain. But this conference that I was at really literally laid out foolproof evidence and experimental data showing that in a wet, noisy brain, that quantum effects can happen. And they happen in these things called microtubules, which are absolutely amazing. I'll just write that out here. So microtubules are these like crazy cylinders that sit in the brain and process information in these spiral patterns. And they integrate tons of information all at once. Each channel around this circle goes into what's called a superposition state. So your brain basically accepts billions of bits of information all at once. It is able to calculate all possible sequences and combinations of that. And then when your brain makes a decision, it collapses the entire waveform. And then therefore, your brain selects a sequence of numbers and digits and words to say. So there is experimental evidence showing that this is happening in the brain. there's quantum superconductivity definitely happening in these parts of the brain. So this whole conference, again, was just an invitation for quantum physicists to, again, make the case that the brain is far more complex than we do believe it is. One of the people that I absolutely want to give a big shout out to, of course, is Stuart Hamroff, who has been absolutely on the forefront of bringing this to the world's attention. Roger Penrose as well has been a huge voice in popularizing these concepts of quantum information in the brain. And then another gentleman I'd like to give a shout out is Anirban Banyapati. He is an Indian researcher in the nano lab in Japan, in Tsukuba, Japan. And he is developing some incredible technology, stuff that will allow you to measure the brain in incredible orders of magnitude to see into the real machinery of how the brain works. And I got to experiment with this technology there. They had a small exhibit that I got to go into, and I just happened to meet him. And he's like, oh, sit, let me show you. And so I was actually able to put a sensor on my forehead that could measure deep brain activity and show me the waveform of my brain working on screen. And the cool thing of this was that in neuroscience labs today, they do electrical monitoring of the brain, but every time you blink, because there's an electrical spark that happens when you blink with EEG, you see a huge spike in the activity. So most clinical neuroscience today that makes a claim that, oh, well, we know that when you see a shocking image, this parts of your brain lights up. That's how that invention of EEG came from 1875, and it hasn't made hardly any progress since 1875. DDG, which is what Anirban has invented, is able to see all higher levels of consciousness without any interference from muscle activity. So you can actually now see into the brain far clearer than before. And what I told him was that as someone who works in wellness and health and peak performance, and I study what really rich people invest in for their health, right? What are people like Tony Robbins using? What are celebrities using for their health? Like, are they really injecting stem cells into the brain? Are they really stimulating the vagus nerve with ultrasound? I mean, are these things really happening? And they are doing a lot of these things. A lot of these celebrities, to understand their brain function, are using EEG and paying a biofeedback specialist thousands and thousands of dollars to make sense of these waves in their brain. And they're looking at such a narrow lens of brain activity. And I think that they're giving some misinformation, truly. But with this new access to this whole new spectrum of technology to see many orders of information in the brain, now, if you went back to a biofeedback specialist who had DDG, dodecagram, instead of EEG, so I'll say EEG, bad, DDG, good, okay? So that's the difference in the spelling here. EEG is bad, DDG is good. DDG, if you have that from a biofeedback specialist, you'll be able to see many orders of brain function and actually identify where the actual problem is located. And so in the next year, I do believe that I will be able to offer some of the first biofeedback with DDG sessions in the San Diego area, first in the world, because I'm going to be the one with some of the first access to this technology. So I'm very privileged that I get access to, again, that's the benefit of going to a conference like this. You get to meet people who are like, wow, you are a neuroscientist, quantum physicist at the cutting edge of this work. Truly am blessed that we could meet. So I will most likely be the one bringing that to the public as one of them. Yes, exactly. So that is pretty exciting work. I'd say that was one of the most exciting practical applications. One of the other ones that I did learn about here through this event was a colleague of mine, Jay Sanguinetti. He's working on ultrasound stimulation of the brain. And they have these big units that emit ultrasound and they focus it deep, deep, deep into the brain, they have to do all this calculation to go that deep in the brain with like thousands of channels of ultrasound, and it's able to correct for the size and shape of your skull and your head and create a beam in the middle of your brain that's tiny, and it's able to change some of the electrical activity with ultrasound in the very heart of your brain. And what they're looking, Tim, absolutely, pick me. Okay, cool. Let's talk next year when that's ready. Sir, I will be talking about it. Trust me. You'll hear about it, right? You won't hear the end of this. But with this ultrasound system from Jay, is they're directing ultrasound beams into the center of the brain to modulate the activity of where the ego is. And they're potentially using this to treat a number of disorders of like rumination, ADHD, these kinds of things. The kind of rumination that keeps you sad, the kind of rumination that makes you just like hate being in your own head. And they can use ultrasound to like momentarily knock out that region just to like interrupt it, right? Because again, in some of the best psychology, we understand that if somebody is obsessed with one detail and you can distract them and change their attention, that is no longer a problem for them. And as long as you can shift attention to something else, that no longer is a source of concern for that person. With ultrasound, you can do that on a neurological level. So you could just have someone sitting there ruminating on something that's kind of makes them sad, something that really makes them sad, something that is debilitatingly sad, and they just can't get out of that thought loop about it. You use ultrasound, you modulate those neurons that are active, and the brain reroutes around it. So you can do an almost instantaneous treatment for ruminating repetitive thoughts that make you sad, 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 which is kind of amazing. Like, that's pretty remarkable. And so that work is being done in California also. So there's a lot of stuff going on in California, I can assure you of that. But that is probably not going to be available for another 2, maybe 3 years. But as soon as that's available, I will be one of the first to let you know. Trust me on that. So anyway, there was a lot. There were some like incredibly, incredibly smart people at this event. I can't even begin to go over it. I feel like I've already pretty much hit the limits of what the main audience is gonna be able to understand. But your brain basically is a quantum computer. We do know that now at this point in time. And that has implications for now the academic world, for the doctor world, and then eventually for the broad, vast consumer. As soon as this percolates up and people go, wow, I have a quantum brain. What does that truly mean? Does that mean that I can create my own reality? Yes, it does. You're not locked into like one or the other. If you can expand your brain into both things at the same time, superposition quantum thinking, then you're able to collapse on one versus the other, not just the same thing every time. So you have way more control. You have way more ability to be versatile in your own thinking than has ever been thought before. So I think that's the biggest takeaway for me, is that your reality is in a way more influenceable than you think, more influenceable than the powers that be are telling you it is, which I think we haven't even begun to explore the implications of what that truly means. But I think you can get an idea that could be pretty huge for most people to hear. So I'm pretty excited. But yeah, so that's it. That's my review of the Neuroscience Needs a Revolution to Understand Consciousness, is that it was a amazing 10 out of 10 event. I think that one moment in time will be a catalyst for some incredible stuff in the next 5 years, just from that 3-day event in San Diego. So, and hurricanes be damned. Hurricanes will never stop the true endless march of science. So cool. Well, thank you guys so much for watching. I'll end the YouTube stream. Thanks, guys. I'll see you soon. I'll see you tomorrow on YouTube's. And then for Facebook, thank you guys so much for watching.